In the last video, I discussed about the conditional probability, right? And we did some examples on that. So in this video, I'm going to talk about the total probability and a very famous theorem in probability called Bayes' theorem. Okay, so both of these will use the conditional probability, okay? So let us take an example that suppose the sample space is the one that has all the outcomes, right? Suppose this is the sample space, okay? And suppose that sample space has two events. Let's say this is A and this is B, okay? And then let us suppose that there is a C event that is crossing both A and B. This is event C, okay? This event is C. Now, if you want to find out the probability of C, then you will have to go to the A and then find the probability of part of C in A. And also go to the B, piece B, and then find the part of C in B, right? So what is the probability of C here? Probability of C will be equals to probability of A times probability of C given in A, right? And then plus probability of B times probability of C in B. That's what you do, okay? This is called the total probability. This is called total probability, okay? That's what it says. If A and B are two events such that A union B, meaning if you combine A and B, you get the whole S. This whole, that red rectangle is the S, the sample space, the total probability, right? So that is the total S, right? And then the probability of event C, the total probability of event C in that sample space is PC equals to PA times PC given A. PA, that piece, times the probability of C in that piece. And next is plus probability of this piece, and then times probability of C in that piece. Okay, that's when you find out the total probability of C. Okay, let us do this. In the above glucometer example, if one glucometer is selected randomly, find the probability that it is defective. So probability of defective. So what was given in the glucometer example? Let me go to that glucometer example. It says that a manufacturer makes two types of glucometer, model 1 and model 1 and model 2, right? It is like this. You see that? It is like this is a model 1 and this is model 2. And both of the model have defective items, right? This is the defective one. You see that? That is the defective one. This is defective. So what do you do? What is the probability of defective in this case? Is probability of model 1 times probability of defective in model 1, M1, right? And then plus probability of model 2 times probability of defective in model 2. What is the probability of model 1? It is given 80%, right? 0.8 times. Probability of defective in model 1 is 10%, right? 0.10. Plus probability of model 2 is 20%, 0.2. Times probability of defective in model 2 is 0.18. That's what it was given, right? Now you use the calculator to find out the total probability in this example. So that will be 0.8 times 0.1 plus 0.2 times 0.18. If you do that, you get 0.116, 0.116. So if you pick if you pick an item randomly or glucometer randomly, the probability that it is defective is 11.6%. Okay, that's what the solution of this first example. Let us do another example, okay guys? So let me erase this and then do the second example on this. So the second example says that a community has 60% female and 40% male, okay? So what it is given here is 60% female and 40% male. Let us do that. So let us see that. Let me divide that. This is 60%, this is 40%, right? So 60% is female and 40% is male, okay? And then 31% of the males are shorter than 5 feet 4 inch, and 22% of the males are shorter than 5 feet 4 inch. So there is a shorter set. This is shorter, right? Let us denote this by S, okay? So what does it say is, let me write on the given thing. What is the probability of male? What percent of are male? 0.4. What percent are female? Probability of female is 0.6. What is the probability of shorter males? It says shorter male is 22%, right? 0.22, meaning that probability of shorter, given that he is a male, right? That is 22%, and probability of shorter, given that that person is female is 0.31. So what is the probability, total probability of shorter people? See, find the probability that his or her height is shorter than 5 feet 4 inches. So if you do that, the S stands for the people whose height is shorter than 5 feet 4 inches. So it will be probability of male. Go to the male and find the probability of shorter in the male. Probability of shorter given that he is a male, plus probability of female times probability of shorter in the group of female. Okay, let me do that in the group of female. So if you do that, you will get 0.4 times 0.22 plus 0.6 times 0.31. If you use calculator, what do you get? You get 0.4 times 0.22 plus 0.6 times 0.31. This is what you get, 0.274. 0.274. That is 27.4% chance. 27.4% probability that if you pick a person randomly, you will get a shorter than 5 feet 4 inch person. Okay, that is the solution of the second example. All right, so the next thing I want to do is I want to write some notes on that. So do you remember that the complement of an event is all the outcomes in S but not in that event? For example, that B here is same as A complement, right? A complement is everything except A. And this is like a B complement, right? You can write B and B complement as opposed to A and B. Okay, that's what it says. If you replace B by A complement, then what do you get? Probability of C will be probability of A times probability of C in A plus probability of A complement times probability of C in A complement. That's what you will get, because A complement is everything outside A. That is the A complement. Okay, and the next thing it says is the total probability formula can be extended to any number of events. For example, let me give you that example. Okay, so that will be clear for you guys. So suppose instead of just A and B, suppose that there are A, B, C like this. Let's suppose that this is divided like that. Okay, just randomly many pieces. Suppose this is like A1, A2, A3 and A4. And suppose that there is an event C somewhere here that is in, like, C is there. So there is a piece of C, part of C in A1, part of C in A2, part of C in A3, part of C in A4, right? So what is the total probability of C then? In that case, you will have probability of A1 times probability of C in A1, that part, plus probability of A2 times probability of C in A2, right? And then plus you continue doing that, okay, until you get the last one will be probability of A4 times probability of C in A4. If you do that, then you will get 4 of these terms, right? In case of the 2 piece only, you will have 2 terms, 1 term and second term. In case of the 4 pieces, you will have first, second, third and fourth. So you will have 4 such terms. That means that given that what is happening here is instead of here A union B was S, but here A1 union A2 union A3 union A4, right, equals to S. In that case, you will have to do for each of those pieces. That is the extension of that total probability formula. Now the Bayes theorem depends on the total probability formula on the denominator, okay? Because you know that, do you remember that? Let me tell you that. What is the formula for the conditional probability? Suppose that you have A and B are 2 events, they are dependent events. So what is the probability of A given B? That is the probability of A and B divided by probability of B, right? If you want to find out probability of A given B, then this is what you get, right? Probability of A and B, this and divided by that thing goes on the denominator. Okay. Now, suppose that in the denominator, let me write down the sample space like this. Suppose that in the denominator, suppose that this is like A and this is like A complement, right? This is B. I'm considering just A and A complement, not the B. And then B is and let me write down B. Suppose this is B. Okay, so what is the formula for the total probability of B? I will keep the numerator the same. I want to keep the numerator same, or I want to use the formula of the numerator separately, because you know the dependent events formula for that, right? And then probability of B, I want to write the the total probability for the denominator. How would that look like? That will look like probability of A and B will be probability of A times probability of B given A. You can write like that, right? That's the numerator formula. And for the denominator, what you can do is you can write probability of A times probability of B in A, right? Plus probability of A complement times probability of B in A complement. That is the probability of A given B. By the way, why didn't I do here for A and B? There are two formulas for A and B, right? One formula is probability of B times probability of B given A, right? And probability of B times probability of A given B. A given B, because whatever that comes here, that goes in the denominator as well. So probability of B times probability of A given B. Another is probability of A times probability of B given A. So why didn't I use this formula instead of this? Because this was asked. We don't know this value. So I should not use the formula that contains A given B. That's why I didn't take that formula for A and B. Because A and B and A are the same. Okay. I didn't use that. I used the other one that uses B given A. So probability of A times probability of B given A. Look at this one. You see that whatever you have separately, that goes in there. Okay. So, and then for the denominator, I'm using the total probability formula. Okay, guys. All right. And you can extend this formula for any number of events, because if there are more than 2, I just took A and A complement. But if you have more than 2, like A1, A2, A3, like in the previous one, then you can use the same formula to find out the total probability in the denominator. Okay, guys. So let us see an example, then the things will be very clear to you guys. I have done that example here in the slide as well, but I want to go over that. Okay, example. Assume that 1% of the total US population has cancer. So what is let us say that C plus is cancer positive, okay? So C plus has cancer. And C minus is no cancer, right? Not -1, just minus is no cancer. This is just a notation. You can give any notation, okay? No cancer. Okay. Also, what is given here is in the testing process, assume that 10% have false negative. What does that mean? That means that probability that false negative means T minus given that he has a cancer. Okay. Probability of T minus given that he has a cancer. Okay. So you see that? Oh, I'm sorry. It is false positive, right? False positive given that he doesn't have cancer. False positive means you have a positive test result, but you don't have cancer. That's the false positive means. So probability of positive test result given that he doesn't have cancer is what? 10%. 0.10. That's given. And also what else is given? And 80% patients have true positive. What that means? Probability of true positive, meaning positive test result given that he has a cancer. That's the true positive, right? That is 0.80. This is also given. If a person is selected randomly, find the probability that he has cancer. What is asked is probability that he has cancer given that he has a positive test result, T plus, equals to what? This is what it is asked. You see that? Probability of A and B. What is the formula for this? So the formula will be probability of this is, let me use the formula. Let me write down here, okay? So you get that probability of cancer positive given that a person has a positive test result is equals to, so probability of, you see that? Probability of C plus times probability of T plus given C plus divide by probability of, you see that? Another thing that you should notice here is whatever you have here, the first term will be exactly the same. Okay, let me write down that. Probability of C plus times probability of T plus given C plus, okay? Next is, that's the opposite of C plus. What is the opposite of C plus? C minus, right? See that? Probability of C minus times probability of T plus given C minus. So all the values are given there. Let us plug in the values. What is C plus? 0. Oh, by the way, I forgot to write that. What is the 1% means? Probability of C plus is 1%, right? Let me write down that here. I forgot that. Probability of C plus is 0.1, 0.01, that is 1%. Probability of C minus will be 0.99, 99% are negative, right? So 0.01 times what? T plus C plus is what? 0.80. And then divide by probability of C plus is 0.01 times. This is 0, okay? 0.80, right? Plus, what is the probability of C minus is 0.99 times 0. T plus C minus. T plus C minus is 10. So if you do that, what do you get? In the numerator, you will get 0.008, right? Because 0.8 times 0.01. And in the denominator, you get 0.008, right? Plus, how much is that? 0.99. That's what you get, okay? So you get 0.008 divided by, how much is that? In the parenthesis, 0.008 plus 0.99. I got 0.0080. Okay, 0.00801. You get basically, let me make sure that I got 0.01 times 0.8. Yeah, that's good. So I got 0.00801. That's what I got. Okay, guys. So this is the chance. So 0.8%. All right. By the way, it should be 0.099, right? If you multiply 0.99 times 0.1, you will get 0.099. Okay, let me correct that. 0.099, okay? 0.099, that is plus 0.099. So if you use calculator for this, you will get 0.07. Let me write down that. If you use calculator, I got actually 0.0747 and then 6. Okay, that means 7.48%, right? That's what I got here, 7.48%. Okay, guys. All right, this is how you use the Bayes theorem. So this is a very short introduction of this conditional probability and Bayes theorem. You have seen some of the conditional probability in your elementary statistics class, okay, but you didn't see the Bayes theorem there. All right. So the next thing I want to discuss is the random variable and the mean and variance of the random variable. You have seen all these things in your elementary statistics class. I will quickly go over it, okay? Let us see. A random variable is a variable whose values are determined by chance. We choose random variable from a sample space. So discrete random variable has finitely many values. For example, if a family have a plan to have 3 children and x denotes the number of girls, then what is the possible values of x? In case of the 3 children, if you say x is the number of girls, then there may be 0 girl or 1 girl or 2 girl or 3 girl, right? That is the x is the random variable. It is a discrete random variable because it has just finitely many values there, right? Just 4 values. So x, if x denotes the number of girl or number of boy in that family with 3 children, then it could be 0 girl, all boys, or 1 girl or 2 girl or 3 girl, right? That's what you get. So if you want to make the probability distribution of this, so first of all, let us write on what is the outcomes in the sample space. All of them can be boy, right? Boy, boy, girl, boy, girl, boy, girl, boy, boy, right? And then girl, girl, boy, girl, boy, girl, and boy, girl, girl, and the last one is girl, 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 right? These are the possibilities, okay? So what is the probability distribution? If you make a distribution like this, x and then frequency or the probability of x, right? Then this is, we list the values of x, 0, 1, 2, 3, right? And what is the probability of 0 girls? 0 girls means all boys, so 1 out of 8, there is only 1. What is the probability of 1 girl? 1, 2, 3. That is 3 out of 8. We did this in the elementary statistics. What is the probability of 2 girls? That will be 1, 2, 3. So that will be 3 over 8, right? So that will be 3 over 8. And what is the probability of all girls? 3 girls. That will be 1 over 8. So this is the probability distribution, right? And do you remember that how did we find out mean and variance? To find out the mean, we do x times px, right? That's what we did. So what is the x times px? 0 times 1/8 is 0. 1 times 3/8 is 3/8. 3 times 2/8 is 6/8. And 3 times 1/8 is 3/8. What do you get? What is the sum? Sum is 6 plus 3 is 9 plus 3 is 12 over 8. That is 1.5 is the mean, right? So mean is basically summation of x times px, right? And we did that. This is the x times px. We find the summation. That is 1.5. Similarly, do you remember how do we find the variance? So what is the formula for variance? Variance is denoted by sigma square, right? Here is variance is summation of x squared times px minus mu square. That is the formula, right? So we need to find out x squared times px to find out the variance. So x squared is 0 squared times 1/8 is 0. 1 squared times 3/8 is 3/8. 2 squared is 4 times 3/8 is 12/8. 3 squared is 9 times 1/8 is 9/8. If you add this, what do you get? So 24 over 8. That is the sum of x squared times px is 24 over 8. That is 3, right? Let me write down just 3. 3 minus mu square is 1.5 square, right? That is 2.25, 0.75. That is the variance. And if you take the square root of that, that is we denote by standard deviation, is the square root of variance. So if you use calculator to find out the square root of that, you get 0.75. That will be 0.87. 0.87 is the square root of 0.75. Okay, so we find out the mean and variance of a discrete probability distribution this way. So we did that already in the this is just a very quick review. Okay, so let me do one more example on that. What it is saying here is, this example is saying that in a clinic, each doctor sees 4 to 8 patients every hour. The probability that, by the way, one of the things that I forgot to mention here is continuous random variable is, I have a infinite number of values because you cannot list like a discrete random variable. And some of the probabilities in of events in a sample space is always 1. The sum of the probability is always 1, okay? Because previously we had a table. If you add all the probability, you always get 1, okay? Now, and we discussed the mean and variance already. So I want to talk about let me talk about, oh, we did this example already, right? We found the mean and variance of this. So one of the things this example is talking about is you need to find the construct the probability distribution here. Okay, it says in a clinic a doctor sees 4 to 8 patients. So x can be the number of patients a doctor sees. It can see 4, 5, 6, 7, 8 patients in an hour. Okay. The probability that the doctor sees 4 patients is probability of x is given as 0.117. 5 patients is 0.123. 6 patients is 0.295. 7 patients is 0.2328. And it is not given. Okay. Find the probability that it is 8 patients. So you know that the sum of the probabilities is always 1. Okay. So let us say that this unknown probability is p, lowercase p. So you write 0.117 plus 0.123 plus 0.295 plus 0.328 plus p equals to 1. And you add these and then subtract from that side, right? So what do you get? You get 0.117 plus 0.123 plus 0.295 plus 0.328. That, and then if you subtract that from 1, you get 0.137. So it is basically 0.863 plus p equals to 1. So subtract that guy from either side, 0.1863, and then minus 0.863, right? So what is p then? P is 0.137. This is the probability that that doctor sees 8 patients in an hour. Okay, so if you want to find out the mean, you need to find out x times px and then sum that, add that will be mean. If you want to find out the variance, then you will have to find out x squared times px, right? For the mean, you do x times px and find out these numbers here. And if you want to find out the variance, you need to find out x squared times px and then add that, right? You add those, find the sum, find the sum. This will be mu. This will be summation of x squared times px. And you need to subtract mu squared from this to find out the variance. We did that in the last example, okay? All right. That was all about finding the mean and standard deviation for the discrete random variable, okay? And the next thing is binomial probability distribution. We have seen that again in the elementary statistics. So binomial probability distribution has just two possible outcomes. One is the success, the other is the failure, okay? So in a binomial probability distribution, x is the random variable, p is the probability of success in one trial, in a single trial, and q is 1 minus p, and then x is the random variable here. So if you want to find out 5 successes, that k will be 5. N will be the total number of trials, okay, and so on. Let us do this example and then things will be clear, okay? Let us do this. Assume that the probability that a baby has brown eye is 0.75. P equals to 0.75. And black eye is 0.25. So black eye is 0.25. It is just the, let's say Q is 1 minus P, not brown eye, right? Is 0.25. If 5 babies are selected randomly, n equals to 5, find the probability that exactly 3, P x equals to 3 equals to what? Have a brown eyes, okay? This is for the brown eyes probability. Brown eyes. Okay, so what is the probability that exactly 3 babies out of 5 have brown eyes? You use that formula. You use NCK will be 5, and then C and then K will be 3, right? And then P is 0.75 to the K is 3, and then Q is 0.25 to the K is N minus K is 5 minus 3. That's what you do, right? You can use calculator to find out that, but you can also use R. Now there is a R syntax. If you want to do directly in R, okay, for probability of x equals to k, in the binomial distribution you do d binom, and then n, and then not n, k, okay? So k and then n and then p. That's what you do, okay? If you want to do by R, in R directly. And then also if you want to find out the probability of x less or equals to k, okay, then it is p binom, and then k and p. See, d is the discrete binom. If you want to find out at a point, if you want to find less or equals to a number, a certain value, then it will be p binom. So for this problem, what will be the R syntax for this? It will be d binom, right? D binom x equals to 3. So it will be 3, and then n is 5, and then what is p? P is 0.75. That's what you would do, okay? So if you want to see that in the R, I can show you that. So let me close whatever I have there. So it will be d binom, and then k is 3, right? By the way, let me click here. D binom, and then k is 3, n is 5, and then 0.75 is the, this is what you get, 2636. That is 0.2636. That's what you get, okay? 0.2636. That is 0.2636. That is the probability that if you select 5 babies, then probably that exactly 3 have the brown eye color is 26.36% or 0.2636. Okay. And there is another example here. This example says that a report from the Secretary of Health and Human Services stated that 70% of the single vehicle traffic fatalities that occur at night on weekends involve an intoxicated driver. Okay, it says intoxicated driver, the probability is 0.70. Okay, if a sample of 15, n is 15. So if p is 0.70, q will be 0.30, 1 minus p. That is the q. If sample of 15 single vehicle traffic fatalities that occur in a weekend night are selected, find the probability that between 10 and 15 inclusive. So what is the value of k? K is 10 through 15. 10, 11, 12, 13, 14, 15. That's what it is saying, right? So you want to find out that probability. So there are 3 different ways you can do it. One is the D binom, and then you do C, 10, 11, 12, 13 and separate by comma. It is like K and P. Or another is D binom, 10 and then this colon and 15. That is same as that. Okay. Or if you want to do that, you can do 15 15 minus 9 15. You are subtracting 1 through 9 from the whole. That is another way. Okay, so you can do either way. So you can do d binom 10 to 15k, n is 15, and then 0.7. If you do that, you will get the right answer. Okay, so let me check how much would that be. It will be d binom and then 10 to 15 inclusive, n is 15, right? And then 0.7 is the p, right? That's what you get. And if you find out the sum of that, let me write down this. You need to sum that one too, right? So let me write sum. Okay, sum of all those values there. I put that thing inside the parenthesis and write the sum. It's 0.7216. That's what I got. The sum of those will be 0.7216. So you get 0.7216 is the total probability between 10 and 15 inclusive. Okay, and similar to the previous problems, there is a formula to find out the mean and standard deviation. Mean for a binomial distribution is n times p, and variance for the binomial distribution is n times p times q. And if you take the square root, you will get the standard deviation. Okay, so let us do that example there. So this example says that a statistical bulletin published by Metropolitan Life Insurance reported that 2% of all American births result in twin. P equals to 0.02. That is the 2%, right? And if the random sample of 8,000 births are taken, n equals to 8,000. So what is Q though? Q will be 1 minus P, right? 0.98. Okay. And you need to find out the mean, variance, and standard deviation. What is mean? Mean is denoted by mu and n times p. That will be 8,000 times 0.02. I think you get 160 for this. Okay. And what is variance? Variance is n times p times q. You just find out. You just multiply those. 8,000 times p is 0.02 times 0.98. Just whatever value you get is the final answer there. And standard deviation is the root. So sigma is the root of the whatever value you get there. That's how you find out. Okay. And the notation for the binomial distribution is B and then NPK. B and PK means binomial distribution with N outcomes and P probability. N is the total number of trials and P probability. That is one of the discrete probability distribution. Another discrete probability distribution. Actually, the normal distribution is continuous probability distribution. You know that from the elementary statistics class. Binomial distribution is discrete. Another discrete probability distribution is the Poisson probability distribution. Okay, Poisson probability distribution will be is basically, it has little different formula for the equation of or the formula to find out the Poisson probability distribution. The formula is this. Actually, I missed that x equals to k here, or lambda here. Okay, or x just. So the formula is probability of x equals to k is equals to lambda to the k times e to the negative lambda over k factorial. This is the formula where lambda is the mean or average. Okay, let us see that. The Poisson distribution gives the probability of number of events occurring in a fixed interval of time or space if the events happen with a known average. Known average means lambda. Okay, and independently of the time since the last event. The Poisson formula is this, where lambda is known as the average occurrence of that interval and x is the number of occurrence you want to find. Okay, and in R you can find out d Poisson to find out x equals to k, and p Poisson will give you the x less or equals to k. That's the R syntax. Let me write down that. Probability of x less or equals to k is d Poisson, d Pois, and then you write down k and then lambda log equals to false, right? And I'm sorry, this is for the p, this is for the equals to. Okay, let me write down p Poisson. For the lesser equals, it is p Poisson, right? And then if you want to find out x equals to k, that will be the d Poisson. D is the discrete, right? So you just do the same thing here. That's how you use in the R. Okay, I'll show you that. All right, and the mean and standard deviation. Mean is lambda, that is the average, and standard deviation is the root under lambda. Okay, or the variance is same as lambda. Mean and variance in the Poisson distribution are equal to each other. Let us see this example. An emergency room at a particular hospital gets an average of 5 patients per hour. What is lambda? Lambda equals to 5. That is the average. Find the probability that the ER gets less than 5 patients per hour. Probability of X less or equals to less than means. By the way, one of the things that you should be careful is less or equals to 4. Less than 5 is less or equals to 4 because you are using the, if you are using R, then it needs less or equals to in R. If you want to use R, you need less or equals to. So less than 5 means less or equals to 4. So what do you need to do? P Poisson, K is 4, lambda is 5, right? And then log equals to false. That's what you do, right? So let me show you in the R. So you got P Poisson, your K was 4, right? And then mean was 5, and then log equals to false. And if you run that, you get 0.4405, right? If you round it up, 0.4405 less or equals to 4 is 0.4405. That is the probability that you get less or equals to 4 or less than 5 patients in the next hour. Okay. And also, what is the probability of getting exactly 6 patients? Probability of X equals to 6. What is the formula? You need to use D Poisson, right? D Poisson, and then 6, 5 log equals to false. If you do that, let me show you that. If you do that, what do you get? So instead of P Poisson, you will do D Poisson, right? And then you do 6 here because we want to find out exactly 6. So if you do that, you get 0.1462. 0.1462. That is the answer for this one. 0.1462. 14.62%. Okay. And the next example here is a maternity ward at Dr. Joe's Favela Memorial Hospital in Manila in the Philippines is one of the busiest in the world with an average of 60 births per day. So the average birth per day in that hospital is 60. That is the average per day, right? So average per day. So lambda per day equals to 60. Okay. Let X is the number of births in an hour. So X is number of births in an hour. What is the average birth in an hour? So lambda hour. You need to find out lambda hour also. That will be 60 over 24, right? In a day there is 60. So that will be 2.5. That is the lambda per hour. And if so, find the mean and standard deviation. What is the mean? Mean is lambda, that is 2.5. Standard deviation is sigma, which is root under lambda, right? That is root under 2.5. You use calculator to find out that. Also, what is the probability that a maternity ward will deliver 3 babies in an hour? Probability that X equals to 3. That is D Poisson, right? D Poisson. 3, and then lambda is 2.5, and then log equals to false. If you do that, you will get the right answer. Okay, let me show you how much would that be. That will be D Poisson, and then what is, you want to do 3, and then the 2.5 log equals to false, right? D Poisson. So 2137. So 0.2137, that is the answer. 0.2137 is the probability that the hospital will deliver less than exactly equals to 3, right? Will deliver exactly 3 babies in 1 hour is 21.37% or 0.2137. Okay guys, thank you.